Here we're looking at Kirchhoff's voltage law, or the KVL. Kirchhoff's voltage law states that the sum of voltages around a closed loop equals 0. Well, mathematically, the sum of the voltages around the loop equals 0. So here is a circuit. Remember, you must have a loop to have a current flow in a circuit. We've got a voltage supply on the left, and we've got 3 resistors. We've got current shown there. Current is flowing from the positive side of the supply around the circuit and coming back to the negative side of the supply. That's conventional current flow. Here's a loop, and we're going to add all the voltages around the loop. Now, if current's flowing out of the positive terminal of something, that's supplying power. If it's flowing into the positive terminal, it's absorbing power. Resistors can only absorb power. So if we look at the current direction, we can see the positive terminal on the resistors is the one closest to the power supply. So I've just marked those in. Now I'm going to mark in the voltages across each thing as a vector. So here's a voltage, it's flowing that way, it's drawn that way. Here's the voltage across that resistor. The head of the arrow is at the positive end, the head of the arrow is at the positive end, and the head of the arrow is at the positive end. So if we now add these around the loop, what we get is the supply voltage is equal to the voltage across resistor 1 plus the voltage across resistor 2 plus the voltage across resistor 3, or I can redraw that as supply voltage minus VR1 minus VR2 minus VR3 equals 0. Because of the direction of the arrows, if we went around the loop clockwise like we did before, we've got the supply voltage pointing one way and the resistor arrows pointing the other way. So we've got Vs minus VR1 minus VR2 minus VR3 equals 0. That's Kirchhoff's voltage law.